So also as in background, mm, this is a follow-up of a previous workshop we did last year, which was physical, and we had many people joining from Reunion, and we did discuss about quite a lot about hybrid power plant and our tools here. So we planned this time, both Megha and I, not to repeat things. But what also came up, what came up as request that there were um, quite some interest in the modeling the environment, and I'll come to more details about it, around which the hybrid power plants operate, be it dynamic modeling, be it other things. So that's what we are doing in the European system. That is major point of discussion or point of presentation for me today. And then Megha will talk about hybrid hybrid power plant sizing, and more importantly, we have planned that in this 4 hour session, roughly the first 2 hours will be used for presentation, and the next 2 hours will be used for an exercise and assignment, which will be in the notebook. So even if you have not done the previous workshop on HyDesign, the HyDesign workspace, and the all the materials, the notebooks there, they are self-explanatory. So you are most welcome to have a look at it after the workshop or webinar. So I'm quite fascinated with the image. I made it using Chat GPT yesterday. What it shows is that it's a utility scale hybrid power plant. uh, Again, like I said, even the name said it's renewable hybrid power plant. It's I'm not going to define the hybrid power plant and other things. I'm also convening a task group on for IEA Wind, and we have taken this as a responsibility to define what is hybrid power plant there, and we will be coming up with a formal definition very soon, in a couple of months from now. So that's an ongoing work. But having said that, what this picture demonstrates is that it's a utility scale wind solar battery hybrid power plant, which is a crucial component for green transition in a larger energy system. And we we are transitioning between typical isolated electrical power system into a sector coupled energy system. So more and more, the environment is also changing. And so we always keep on saying what is hybrid power plant is. It's it's a tailor-made solution. It's a mm, uh, bespoke bespoke solution. So there is not a mm, general hybrid power plant, if we may say. So it is it provides what the environment asks for. So what we are trying to model is the environment as well. And the major part of the environment is the energy market or the electric. The talk will specifically focus on electricity market, but it can be broader energy market with other sectors involved, like be it hydrogen or heat or transportation sector coupled together in defining the broader environment on which we need to develop and operate a hybrid power plant. So again, not going into the technical details about what is a hybrid power plant, and I would like very much this to be a um, uh, that there are ongoing discussions. So please stop me within that slide. You don't have to wait 2 hours for any question. And maybe Matthew, you can have a look if there is something coming up in the chat, please. So if you have a question, just let us know. So this figure I think is drawn by you, no, Megha? Yeah. I'm sorry, I forgot to give you the courtesy here. But so you can see here the wind power plant and solar power plant and energy storage, everything is combined and co-operated. They are co-located, of course. They are co-operated and they have a single point of connection. One, two, yes. So they have a single point of grid connection. It, it's not necessary to have a single point of grid connection. It can also have a singular consumer directly connected, but a majority of the focus of what we do is that it is connected to the grid, and then the grid and the consumers are connected to the bulk energy grid. So we are not directly connecting to the consumers. Rather, we are uh, designing the hybrid power plant to provide the support to the larger grid. And we are developing this more from the perspective of the hybrid power plant developer and owner. So they are trying to maximize the value for their own power plant, and which may not be always in tandem with the energy system minimizing cost. And this is understandable as well, right? So the typical paradigm what we had in wind plant design or solar plant design for that matter is to minimize the cost, so to provide the cheapest electricity. But if you want to design a hybrid power plant with minimization of cost as an objective, then you will never put an energy storage system, because the energy storage system does not generate energy. It stores energy, it charges energy, it discharges energy to the battery. But over the lifetime, it's a lossy medium, right? So it's basically a load. Why would you, as a generator, put a lossy component which costs you money if you want to just minimize your cost? So there is no value of hybrid power plant. But at the same time, what we see day in, day out, that there are many hours when wind and solar are not available, or uh, the prices are very high, and then those are the hours when the energy storage might play a big role in providing cheaper energy. If you can store that energy into the energy storage during the hours when the wind and solar was high and the nature was generous. So what is the motivation of the hybrid power plant from system operator societal point of view? So it might sound a bit capitalistic that I have been saying that we are designing it from the owner's point of view, but that's not necessarily true. Why the hybrid power plants are generated and being developed all around the world? One of the major reason is that delayed requirement for transmission infrastructure reinforcement. Like one thing is that the cost of transmission infrastructure reinforcement, but it is also quite time-taking affair. So if you want to put a 100-kilometer transmission line, you have to do all kind of planning studies, you have to do all kind of land acquisition, you have to do the construction, and it can easily take tens of years, right? So you have to wait 10 years to get the grid reinforced before you can connect your renewable plants. And we see this all over the world, that all the operators, they have a huge list of requests to the permitting agency, and then there is a backlog on the permits because the grid is not ready. So I'm going back to this figure. What you can see, if you assume that the grid connection here is, let's say, 100 megawatt. So what it allows you to connect much more than 100 megawatt, typically two times or even more of renewable plants beyond this connection. So with the given grid connection, you are able to connect much more renewable into the system. So that's a major win toward green transition. That's the second point as well. The more renewable integration with the same grid connection, optimal utilization of the land, so you can start putting them closer. And if a single developer developing it, so you reduce the wastage of land. Of course, your hybrid power plant has much more availability, and so it can provide the stability and the ancillary services much more than an individual wind can to do. Having a battery also means you have much more capabilities to provide those ancillary services. So that also provides you much more flexibility and much more capability. Increased capacity factor. In general, uh, wind will, in a good onshore location here, would have something like 30% capacity factor. We are not having that good solar conditions that can be having 10% capacity factor. But when we combine them, even with a little bit of curtailment, if we don't have a battery, we can really get 35%, 36% capacity factor. So that's already increasing the capacity factor of of the uh, of the renewable. That also means that grid is better utilized. And then if you have battery, you can also reduce the curtailment, means that you are not spilling away the renewable energy. But like I said, the motivation is mainly from the developer and owner's point of view. So cost reduction, of course, like in infrastructure cost, like reduction in the land cost, optimal utilization of electrical infrastructure and other infrastructure, saves the cost. And then project development, like permitting in itself has a huge lag period in major reality of a major part of the world. So you can reduce the cost of permitting, you can reduce the risk of developing the plant, and then also you can use joint site development and the shared resources for electrical system development and all those things. So those can also reduce internal cost. But most important, part performance can increase quite a lot, like less fluctuating production, better electrical infrastructure utilization, increase in the flexibility. Again, these are quite similar to what I was saying in the previous slide, but now we are talking in terms of uh, power plant owner point of view. That means you are basically trying to maximize the profitability of the plant. In that way, you can uh, move away or decommission other plants like a thermal power plant. In many parts of the world, I come from India and Mega also come from India. Wind is not available all around the country. So having a hybrid power plant can have that kind of capability or capacity factor. That way it can beat uh, thermal power plant and be a competitive technology there. So we made a map last year. It might need to be updated. This was done by Guji, who was our PhD student at that time. And you can see that quite a lot of hybrid power plants are growing all around the world. And there is a website in Wind Europe which has not been updated lately, but I think it has been updated in 2018 or 2019. And there you can see that Australia, India, and now US picking up. These are the major countries where hybrids are growing. We are also seeing them in the Southern America and also more and more in Europe. In Netherlands, offshore hybrid has come up, at least under development. No, not Holland, Holland Coast, and more so in offshore hybrids are coming. There are plans to develop also offshore hybrid in Denmark. When I say offshore hybrid, it does not necessarily mean all the components are offshore, but at least the wind farm is offshore, and then they can be hybridized either onshore or offshore. In the Dutch water one, they have floating solar, but in the Danish waters, they are going to be onshore solar and onshore battery and onshore power plants. At least that's the plan for now.